Okay, so today I'll be doing chapter 16, number 81 in our physics notebook. So it states, one way to monitor global warming is to measure the average temperature of the ocean. Researchers are doing this by measuring the time it takes sound pulses to travel underwater over large distances. At a depth of 1,000 meters, where ocean temperatures hold near 4 degrees, the average sound speed is 1,480 meters per second. It's known from laboratory measurements that the sound speed increases 4 meters per second for every 1 degree Celsius increase in temperature. In one experiment where the sound generated near California are detected in the South Pacific, the sound waves travel 8,000 kilometers. If the smallest time change that can be reliably detected in 1 second, what is the smallest change in average temperature that can be measured? So that is our actual question. If the smallest time change that can be reliably detected in 1 second, what is the smallest change in average temperature that can be measured? Okay, so I just highlighted what's going to be important here, which is the average sound speed. The speed increase per temperature per degree, and the distance the sound wave travels. So our first step is going to be how much time it takes to cover 8,000 kilometers. So for that, we're going to use this equation. The time equals distance divided by velocity, and the velocity is the speed, the average sound speed they give us. So if you do that, you will get 5,405.4 seconds. So in that amount of time, it covers 8,000 kilometers. So the question states that the smallest time change that can be reliably detected is 1 second. And for that reason, our second time is going to be this time plus 1, because that's the amount of time that can be reliably detected. So that is our second time. So now we're gonna we're gonna get the velocity for T1 and T2. So for T1, they already gave it to us, so that is what we had the first time, which is 1,480 meters per second. And then for the second time, we're gonna use what we just calculated, which is this number. Just plug that in, and just reminder, velocity equals distance over time. So that is our velocity for time 2, which is 1,479.73 meters per second. All right, so for our next step, we're gonna find the change in velocity, which is 1,480 minus 1,479.73 meters per second. So that is our change in velocity, is 0.27 meters per second. And now just a reminder that the problem stated speed increases 4 meters per second for every 1 second. So that is why we got our velocity, was because that is the relationship they gave us, which is the velocity and the temperature. The relationship between the two, which is the speed increase change of 4 meters per second for every 1 degree Celsius. So we're going to relate this by the change in temperature is going to equal to 1 degree Celsius divided by 4 meters per second times the change in velocity. So if you plug that in, you get the change in temperature is 0.0675 Celsius. So about 0.07 Celsius. So that is the amount a change in temperature that can be reliably detected. And that is our final answer.